Now we have the next part, which is the tailstock. So the purpose of the tailstock is basically to support longer workpiece. For example, this is a longer one and this is made to rotate. It may, it may not be rotating along its central axis, but there will be some eccentricity to that rotation. To stop that, we support the other end, which has sharp end. So we can see that the end of the tailstock is pointed, so this part will be supporting it, and so you have a support, and there are other purpose for tailstock also, especially when we are doing some sort of something called tapering and all. We will see in the other part of this lecture. Now this tailstock has got different parts. There's a wheel in which you can move this tailstock, this shaft, this dead center shaft, in and out. The whole thing can be moved. It can be fixed onto that. There's a lock nut which you lock it and keep it there. So the tailstock, there's a spindle where you can loose it and take it out, and so all these provisions are available in the tailstock. Now, so this tailstock is connected. You can see that there are some guideways. You can see the guideways like a railway track. So the tailstock is fixed on this track, and it will be able to slide on this track depending upon how much length and support you need. Okay. Now this headstock and tailstock, it is supposed to be aligned in a single line actually, and there are situations where we need some changes in that alignment, and we maybe sometimes we need something. For example, it is generally in alignment. This is a tailstock, this is a headstock. So if you are actually require something, some sort of tapering and all, then you may have to you can have something like some workpiece have to be kept like this. So it will be fixed like this. So your it will not be supporting exactly, this will not be a perpendicular one, but it will be connected little bit tilting. So now we can use something called tapering and all when you have a diameter, a rod with one side diameter is bigger one, the other one is a smaller one. So such things actually can be done when we are using this non-alignment of these headstock and tailstock. All right. Now how do we hold this workpiece to the lathe? There are different mechanisms in which we can hold these things to the headstock. For example, the main one, which is called a chuck, C-H-U-C-K, chuck. This can have different jaws. So the jaws, when we are tightening the screw, the jaws will come together and hold it like this. It can be 3 jaws or 4 jaw chuck. Okay, 4 jaws is exactly the one which you see in a drilling machine. When you tight it, something comes and hold that drill bit. Exactly the same thing happens in a jaw. There is 6 jaw. There is even 2 jaw chuck also, and there are something called collet chucks and face plates and other things to hold these workpiece to the centers are there, like where you can centralize and keep it. So these are different chucks in which this can. This is a workpiece. You can see a person standing here. The workpiece is so huge, but we still have some mechanism to hold it and make it rotate. So he's doing some work on a big workpiece, maybe a ship part or something, So these ones are the one I was talking about. This is 1, 2, 3, 4, 5. There are 6 jaws. So the 6 jaws will be coming and holding it. This is a 4-jaw chuck. So when you have a key here, when you tight the key here, these jaws will be coming together, and if you loosening it, it goes away. So you can actually fix a workpiece of different diameters according to how much extent these guys are able to move out and all right. This is a very common 3-jaw chuck, which generally we see in the drilling machine and all. Yes, students, so we were discussing about different work holding devices. So after the chucks, we have something called the face plates, where we have slotted holes there, where in which we can fix attachments like this, onto which the workpiece can be fixed. Different shapes and sizes of workpiece can be fixed, like using these types of nuts and bolts, as you can see. Now collet is another type of chuck, where it's a self-locking chuck. You put it in, it's self-locking and it locks by itself, and you need to push in the thing, it gets locked and it will not come out. So these are called collet chucks. It's a type of chuck. You can see the jaw and all. Now if you are going to the market to buy a lathe, how do we specify the lathe? We need to specify certain dimensions in the lathe to properly get the particular type of a lathe. Now let's see what are these dimensions, what are these important ones. Now if you see the schematic diagram of lathe, we have the headstock, tailstock, the bed, carriage and all. So some of the major specifications or dimensions are the length of these ones, the bed through which it can be moved, the diameter of the maximum size of the workpiece which can be rotated. So this is the D, you can see. If the diameter of the workpiece is more than this, you connecting to this, you are attaching it to it, will not be able to, it will hit here, or it will not be able to hold it onto the chuck. So this diameter, this length, and there are a lot of other things. Now let's start with the length of the bed. It is approximately the floor, the bed. Now the length between the centers, this is from this tailstock to the headstock, that maximum length is the second dimension, which is very important. Then height from the bed, as I said, that is the surface in which it can, the maximum bar diameter, that is something which you can hold on to the chuck. If the chuck can't hold a diameter is more than that, then you can't work on that piece. So the bar diameter is another important one. The swing diameter is the diameter of the work over the bed I was discussing, and the swing diameter of the work over the carriage. So it should not hit the carriage also. That's another parameter which we have, that also makes a difference in the specification. So these are some of the important specifications that we have in lathe. All right.